always a great pleasure to speak here. And well, this talk may be seen as a complement, a continuation of a technical side of our key speaker we've just had half an hour ago. So I will try to provide some real figures and show how effective AI is today looking at PDF documents in the real world. So very quickly, this is a joint work and a joint project of our company in Hong Kong, where we are trying to build a hybrid system, actually, that recognizes the structure of PDF documents. To those who is interested what it is, please come to tomorrow's solution poster session. Well, objectives, well, first of all, what is the motivation for us doing this analysis? Well, first of all, we've been working so much on standards here under the roof of PDF Station. So it's a validity check to understand how many standards and how are used in the real world. So that was probably one of the key motivations. But of course, there are many more. We wanted to see like how feasible it is to just analyze all PDFs in the world. We've seen that the recent success of GenAI is based on the fact that they were able to be trained on essentially all data publicly available, even not publicly available. So we've seen maybe there is a chance to analyze all publicly available PDFs. And in this case, we speak only about PDFs available on the web. And well, we wanted to see what is the current state of AI on analyzing PDF documents and extracting data. When I say analyzing, it's mainly layout recognition or data extraction from PDF documents. So there are a few models already available which seem to be quite efficient, and we wanted to see how really they're efficient. And of course, one of the additional goals was to see if we can collect really good PDFs that can serve as new training and test data for new models. So data set. So what was really analyzed? And this is actually not 8, but 15 million of PDF documents, no exception here, all taken from Common Crawl. So Common Crawl, I'll speak very soon what it is. Yes, so I actually covered this slide. So standards development, build collections. Well, it's also important to mention that what was done was not unique. So analysis of real-world PDFs from Common Crawl was already done to some extent during SafeDocs project, where PDF Station was also taking part. But that was mainly analysis of very basic metadata, while what we were interested in is well, tagging, semantics, and accessibility aspects of PDF documents or reuse of PDF documents. So PDF UA and reuse that come very close together. And so this is Common Crawl. So for those of you who has never seen this, that's an open source archive of all data available on the web. So essentially, this is a collection of just URLs with some very basic information what is in these URLs. One of the main metadata is, of course, MIME type. And what I show here is one of the latest crawl, at least it was latest when I was doing this presentation. They are updating these archives 3 or 4 times a year, so maybe there was already new published. So the latest call from, it was May, June 2025, had 14 million PDF documents of MIME type application PDF. Of course, this doesn't guarantee that if you start downloading these files, that would come as a valid PDF document. Not everybody really takes care of correct MIME types, but in general, this works. A very first statistics comes here. This is how this MIME type application PDF compares with other MIME types. It was a bit surprising that application PDF is second most popular URL, MIME type for all URLs on the web. So first is text HTML, which is, well, kind of obvious. The percentage is a bit disappointing. So you have 98.8 HTMLs, and comparing to this 0.85%, or 58% of PDF documents. Still, it comes as a second, with quite some gap between the third in terms of factors. Not absolute figures, but in terms of factors, the third one is, XML. So at least that shows that PDF is really very popular on the web. Well, of course, if we don't count HTML. I was saying about 15 million documents we analyzed, while here we've seen only the figure of 14.1 million. That's not exactly the same figure. And we were trying to be as accurate with numbers as possible because the final results come as statistics. So doing any statistical research requires to be very, very careful with all the data you deal with. So we tried first, our first attempt was actually to reuse SafeDocs corpus that was created from a much older crawl from 2021. And it contained 8 million PDFs, which were, well, they said that it's untruncated, and they stored all these PDF documents as they're still stored, publicly available. It's about, it's about 8 terabytes of data. So it's 8 terabytes of archive stored in the cloud. So we picked up those files then, but then realized that, well, it's only the data up to 2021. Maybe there is something more interesting going on now. So we wanted to take the latest scrolls, and it turned out that it's still, of course, time-consuming to download all these URLs and check for the validity. So it takes time, but not as much time as any further processing would take. So just downloading these files and storing them on the web is not an issue today. Well, no, terabytes, but well, there are many, many platforms that provide you a way to store such large collections at a very reasonable cost.
But when you spoke about 50 million, it's roughly half and half. Half is
so,
older than 4 years and the other newer.
Yeah, it's a bit more complicated. I'll explain now. Yeah. And actually, this is where we probably made a mistake. So instead of reusing SafeDocs, we should have reused the latest scroll right away. So we went to the latest scroll and started downloading them all. But of course, there are duplications between what was previously downloaded and what is available now. We wanted to remove duplication by a very simple trick. So we just, to avoid duplication, we looked only for PDF documents where modification date is greater than September 2021. Surprisingly, in total, we got more than 14 million available in crawl now, because some of these links which are now in SafeDocs were probably removed and are not available now. So in the end, we've got 8 million files from SafeDocs corpus from 2021, plus additional 7.2 million files, which are recent ones, from the recent crawl, just to be precise, and have modification date greater or equal than September 2021. And here, the first surprise came out. 3.5% have no creation or modification date. We got used so much that all PDFs have proper metadata in there. So either information dictionary or XMP metadata have properly recorded creation or modification date, and that's all in the standards. However, more than, well, close to 500,000 documents just don't care when and why they were, when and how they were created. You of course are curious to know what happens here. You look at some random number of such files. It turns out they're just scans. So apparently there are some scans that produce PDF documents, and these scanning applications, it's so much more important for them to capture the image than to put correct metadata. So they just don't put any metadata into the files. So that was a very first surprise that of course, when we see such number of files and we don't know whether they are duplications or not, we just skip them. So, and this is the practice we did. So as soon as something doesn't work, we just skip files from the analysis. It's kind of a cleanup. We hope that this did not disturb statistics very much, but still I'm saying right away that there was some cleanup on the way. So in total, finally, we had 15.2 million of PDF documents with close to 20 terabytes of disk space occupied. And this is how they were distributed across the dates. And you see already that 2021 is much larger, or not much larger, but larger than 2024, and 2025 is not yet completed. And again, we figured out that the reason is exactly because we were gluing two collections. And because their age is exactly at 2021, we got quite some more files created at 2021. So I have to admit that in the future, if we are going to repeat this, we are not going to go this way, and we'll always just download all files from curl without trying to glue them with something created earlier. It was just so promising that somebody has done this before us, and we wanted to use it, that we got this combination of two collections together. And you see a slight distortion here. For the rest, it's more or less clear that 2025 there are more documents than 2024 and in the earlier. So the number of PDF documents, absolute number of PDF documents on the web is growing. But all pages are growing, so it's always also important to compare with the percentage against HTML, for example, rather than look for absolute numbers. Again, of course, you look at the very basic statistics. And for example, the very first one you think about is PDF files by version. And of course, when we speak about versions, this is a version that is declared in the header of the PDF document, but also in the catalog. So not surprising that we have this data here. So the majority, 1/3 of PDF documents is marked as 1.7. The next one is 1.4, which is 4 million. And this kind of aligns us with most popular standards, 1.4. And then there were many updates. And then there was yet another stable standard, 1.7. So this is put into red box, which was really surprising. These are all valid standards, 1.0. There are still 5,000 documents with version 1.0. Only 6.6 documents, 6,600 documents which declare version 2.0. This means that PDF 2.0 is not yet here, actually. So we have less 2.0 documents than 1.1, for example. And of course, what comes on the right is just fun. So you have these are versions you see in the spec on the web. They do not exist in any specs, but still, maybe for some experiments, maybe by error, people were generating them. But they really can be viewed as just outliers and can be removed. They're really marginal numbers. Still fun that somebody, like 19 files with version 10.0.
It was a marketing trick.
Well, yes, 1.8, 1.9, so there are some. Well, size of PDFs, that's also quite interesting to understand, and you see this almost normal distribution here. So it's really, well, again, something you would expect out of Scratch, that it's with so many files in the collection, so you would have the law of large numbers working, and you would have something like this present. And what's probably most interesting for us to see here that so the average of PDF, so maximal number of PDF documents in this diagram, the pike is around actually 200 kilobytes. So the majority of PDF documents, well, no majority, like median of PDF documents is here. Of course, we have much larger documents, and that was very interesting also to see that we have more than 1,000 documents which are of the size of 256 megabytes, which probably those who deal with PDF development have seen such files in practice. So it's not surprising that such files exist. So it was really interesting to find out what is the real maximum. And this is the maximal document size. So it's 5.5 gigabytes. This is a file available on the web. So this is, if you're dealing with implementation and you're looking at what implementation limits you should support. So this is about where you have to go. So maybe it's not practical to go above 10 gigabytes, but there are still files that are above 5 gigabytes. And well, your question, of course, who can create such files? And that's, again, not surprising. This is just a scan, a high-resolution scan with 858 pages. So, of course, putting too many high-res images together, you end up with a document of that size. And we have inspected 10 largest files in this collection, and they were all of this kind. So maybe they were even coming from the same application. Yeah.
Was there any analysis whether they used the proper features? Was that 5.5 gigabytes compressible to 10 megabytes?
No, that was not done. But that's when actually, as first questions show up, I have to tell in advance that, well, as I was expecting that people would be interested in more data, more questions. So we have set up a Google form where you would be able to submit your own questions. And if we have this data available, if we don't need to rerun analysis of, again, of 15 million documents, then we would reply to your questions as soon as we can. So the QR code to this link to this Google form will be available at the last page of the slide, and we'll also distribute some printed QR codes here. Yes?
And do you have a statistic how, because I see in your presentation that the size of the PDFs looks like it's going up. So if you have a year by creation or something like that, do you have a statistic?
No, well, we can extract it easily. So that's another question. Feel free to submit it, and we'll provide the data.
Okay.
That's well. You see, there is like infinite number of questions you can ask, and we didn't know which exactly questions are interesting. So we wanted to give people opportunity to ask this afterwards. Well, number of pages, that's another very basic statistics. And here we have, again, something like logarithmic distribution. Probably that's another very standard distribution here. And, well, again, the majority of documents have only one page. So it's one-page documents that are like, are really here. And in general, like most of the documents have not many pages here. Those are still like the same 1,400 documents that have more than 2,000 pages. And again, we look at what is the maximal number of pages, and here we come. The document with almost 39,000 of pages. Well, the size is not large, and from the creator, you probably guess that it was just an export of very, very large, I don't know, transaction collection or whatsoever. So in Excel, from time to time, you get a lot of data, and someone wanted to save it to PDF. So it's not really something that is very surprising. What was really surprising is that the document was tagged. So this export was supporting tags already, and it was fully compliant to the parent-child relationships as specified in PDF 2.0 and a very recent standard ISO 30005. So even if such huge PDFs are exported, that's done in a very proper, accessible manner.
So this was tagged from Save As PDF, or was it more advanced? Do you know? by the sample?
It's very difficult to say this.
But
That's
where
maybe a
are-
question to forensics group, where they really would understand how exactly the document was produced. We've seen only creator and producer, and we didn't do further analysis of the document. But again, we can bring such document for manual inspection to anybody who is interested. As maybe 10 more documents of this kind. Well, scanned PDFs. So there is, of course, a standard question where how many PDFs are digitally born and how many of them are just scans of the existing paper documents. And again, we were really surprised to see that the number of scanned PDFs is quite large. We wouldn't expect this, so it's more than 10%. Around 12% of all PDF documents on the web are just scans. And again, we have to be careful, so what is the definition of scan, because that you have to understand that that was analyzed in a purely machine manner, not a human classification. So we classified a document as a scan if it had only images and page contents, nothing else. So maybe there are more than just scans, maybe somebody just saved an image to PDF, but I guess in majority of cases, these are just scanned PDFs. So on the other hand, that's good news. So close to 90% of all PDFs are digitally born today. And well, this is a typical extract of what we've seen looking at, so a lot of legal documents actually. I didn't want to put any sensitive data. I didn't know to which extent this was really properly. If people just put some legal documents on the internet by mistake, so we have to be careful with such things. Now we moved now towards tagging structures and accessibility. So far that was just a basic metadata. First, and I'm sorry for maybe low quality here, that's just extras from some Python applications. And so first, the percent of tagged PDF documents. And percent of PDF documents are now by timeline. So that was your question, how these things change by time. I thought that's really important to see how many, the percent, the share of PDF tagged PDF documents by time, how it evolves. So the good news, now we are at the stage where about half of PDF documents are tagged. Which is, again, I wasn't expecting this number. I thought that people still are not really eager to generate tagged PDFs, even if this functionality is fully available in all software. But yes, we are at the age where probably in the coming year or two, you'll see more tagged PDFs than untagged PDFs. And again, by tagged PDF, we meant any document that had structure tree. Actually, that had structure tree root in the catalog, to be precise. And we will see that it might be also a little bit disappointing. Again, we have like here very strange data, but it's 2021 year, so I would assume that that's again caused by our way of gluing two data collections together. Yep.
Is this modification or creation date?
Modification. So we were gluing documents by save docs plus any documents available now, but which have modification date greater or equal 2021, or if modification date is not available, then we were looking at creation date. So that's very detailed, precise. Yes, there was. You wanted to ask also a question? No. Okay. Well, then we were of course interested in extreme cases. That's always fun. So what is the largest number of structure elements? Well, 18 million. Well, just about 500 pages, file is small, but structure tree is really huge. And again, this is an indication which, suppose you want to create a structure tree and keep it in memory, you have to be precise, you have to be prepared to keep these large tree data structures in memory. Structure tree depth, so that's another measure of complexity of your structure tree. And that is really interesting. So a lot of files have very, very small or very, very small structure tree actually. More than 100,000 documents have nothing inside structure tree root, not even a document. So they put structure tree root but forget to do anything else. So probably it would be fair to say that these documents are not really tagged. But we were treating them as tagged PDFs. Well, around 5 or 500,000 of documents just were putting a single maybe document structure around all the documents, because this is maybe a requirement by some of the policies or standards that the document is tagged, and it's sufficient to just have a very small effort to make your document classified as tagged PDF.
It could also be a lot of P's on the structure tree root level,
Yeah,
right?
just the
Yeah,
paragraph.
yeah, very flat structure is, yes, that's also correct. But, well, there is a reasonably, well, the majority, again, the median here is around 4 to 7 elements, 4 to 7, depths of 4 to 7 elements. But we also have extreme cases as usual, and here's an extreme case. So we have a document that has depth of the structure tree of 480. I can't imagine what it could be. And again, that's a very small document produced by Quartz Express, just 2 pages. But outrageously deep structure tree inside. Okay, so which elements were really used? That's the next thing. So we wanted to see whether, well, maybe new PDF 2.0 elements are used, and maybe some other were in particular, I was really interested to see whether Very2 and Ruby are really used. And, well, we've got some. But, of course, the left, so this is not the complete table, of course, because there are more elements. So on the left, there's like top 8 elements in this table, and on the right column, there's a bottom maybe 8 also elements, a bit more because I combined them into here. So not surprising that paragraph and the table cells, like this is probably really the core basic blocks of any structure tree. So this is the majority of tags we see in the documents. I was interested to see that, yes, there are some number of documents that have Ruby, very few that have Very2. So Very2 came, well, for those who doesn't know Ruby and Very2, these are special tags used in the Japanese scripting. And when I was always dealing with implementations of PDFs, well, I haven't seen any single real-world documents with these structures. But they exist in HTML as well, so they were copied into PDF. And yes, there are very few, but still some documents that use them. On the bottom, we see BibEntry. So BibEntry is very rarely used, less than private and Ruby. That's also another indication that maybe that's not something very, very useful. And zeros are really a surprise. So not a single document uses EM strong. Well, RP and VP, again, this is a very special things from Ruby and Very2. But EM and strong seem to be so much natural, and they exist from, well, from all versions of PDF when tagged PDF was introduced. Not a single implementation uses them. At least they probably support them, but users do not see this as something important to put these structures into the structure tree.
Or too much effort.
Or maybe too much effort.
It might change. I mean, we will output them automatically, basically.
Yeah.
And then you will have some on the next scan.
We'll see how many publicly. Well, if LaTeX goes to archives, LaTeX project goes to archives, and we'll see millions of documents with very nice tagging structure. Yes.
Yeah, but they're old things, not used in HTML5 anymore.
Well, maybe that's also another reason. Well, thank you for comment. Well, new PDFs. So these are all tags that were introduced in PDF 2.0. 0 of them in spec, but that's again because we have very, very few PDF 2.0 documents yet in the field, in the wild, to be precise.
Accessible to you, to be precise.
Yeah, accessible to Common Crawl, just to be precise. we don't implement our own crawling because that's by itself a very delicate and difficult technology. So we just reuse the database that is generated by efforts of other people. Documents, well, so far that was just the total count of all elements. Then how many documents there are that contain this or that tag. And again, well, again, P and span and win by a large number. But well, P wins by a large number. Document is here next to span. So this means that a lot of, that's again not surprising because a lot of tagged PDFs will have document as a root of the structure tree. Yes?
One question. I mean, this is only tag documents. Obviously.
Yes, of course.
What's the number of tag documents in your collection? Because I mean, I would expect a tag document to contain at least one P. What would be, or document would be my expectation.
Yeah.
So how come? What's the
Yeah.
relation?
Okay. So I didn't present this earlier, but that's a correct question. So we had 15.2 million documents initially. During the cleanup, we got probably down to 14 million because some didn't have creation or modification dates, some were broken, and 50% of them were tagged.
Okay.
That's 50% today are tagged. So previously there were less documents tagged. So I would say that in total we have, well, Denis, my colleague sits here. He's probably looking now at exact numbers now. But as far as I remember, it was around 4 million of PDF documents that were really tagged.
And 5,600,000.
Yeah, then it's 5 million. Yeah, yeah,
P. So
yeah. That's probably almost the total number. Sorry,
It should be the
Yeah,
total
yeah, yeah.
number I would expect,
Yeah.
but
very close. So, well, I'm looking at Denis now. He might provide this exact figure. I'm sorry, I didn't include this into the presentation, but certainly we do have this data. Well, next, what was happening? So we have just as a background for those who hasn't seen this, both PDF 2.0 and there is a recent standard called ISO 32005 include an attempt to define a schema for the structure tree, and in particular, they define all valid parent-child relationships. So which elements can be contained in which and how many in which situations. So validation against these rules was implemented by VeraPDF a while ago, but it's constantly evolving because there are new drafts of this specification are coming to the market, but at least it's some level of guidance. Not definitive yet, and we wanted to check how many documents how many errors and of what kind we'll see in real-world documents. And by large, the most typical thing was this one. So if you don't see it, it's span inside TR. Lots of documents put span inside TR, maybe for lines, for table borders. And I think that was very valid practice in PDF 1.7, and it is forbidden by this specification, but still that's indeed a very common practice. So maybe, again, because of some popular implementations, we're doing exactly this, saving documents to PDF. And here we have many other things like there are spans in table of content. There are links that are put directly into table of content item. That's a very typical use case. Non-standards tags used a lot. And well, here's it's top 20 errors here. So we see here at least what people are doing now. And we have figure and P put directly into structure tree root, even if it's kind of forbidden. Well, maybe there is this analysis here that is more understandable than these tables. So span inside TR, that's maybe the most typical thing. Inside TOSI, so people think that you can just put any inline elements inside TOSI. This is why you end up with direct content spans and links inside TOC items. We've seen many elements like P, figure, select, art, part, span inside document. And strictly speaking, only part art and sect are okay in PDF 1.7. But well, again, users are more inventive than specifications. And quite some documents had no document inside structure root, but again, that was okay in PDF 1.7. So if we ignore, in total, 44% of documents were fully compliant. So I think that's already a huge number. So, and if especially we ignore those errors that were okay in PDF 1.7, but are not included into ISO 3205, then the number grows to 63%. So to say, well, 60+% of tagged PDF documents are really very good from the structure tree point of view, but not the rest.
And if you take the top 5 and say those, ignore those, how would the number go up then?
Again, another question. I don't have an immediate answer now, but we would be able to.
I mean, if you have something like span link
Yeah.
content inside TOC
Yeah.
CI, and there's a good argument why this
Yeah.
makes sense.
Yep.
We had the discussion on that one. And if this is a huge portion making things incompliant, it would be interesting to see.
Yeah, that's what we did part of this. So we already looked at removing or ignoring errors which are okay actually, which are not errors according to 1.7, but not exactly these ones. And well, thanks for the question. We'll certainly run this as well.
44% and 63% is surprisingly high, to be honest.
Yeah.
Do you have any correlation between the complexity of the documents and the correctness of the documents?
No.
I'm wondering if these are maybe mostly very simple or trivially simple documents that are correct.
Yet another question we would be able to answer if you submit it through the forum, or I'll remember it. I'll submit it for you. Yep. Yep. So yeah, I have to go faster to reach AI. So one of the questions we had was how AI is good to understanding the structure of PDF documents. And we tried to do the following experiment. So we selected a nice use case that's stacked PDFs with good tables in the structure tree. So we selected potential positive cases, so documents that have tables comply to all the standards, tables are regular, bounding boxes. We also analyzed bounding boxes, so they're not distorted, but they'll go in the right order. Well, we also had a few potential negative cases, tagged PDFs which have no tables, but we run a Hancom PDF open data loader, that's a hybrid system for table detection, that still was detecting some tables inside. So maybe there are tables, but people didn't tag them as tables. So in total, we selected relatively small number of 440K documents, but these were then analyzed to went through the AI model. And this AI model was chosen, we've chosen DocLink. That's one of the probably most trending today AI systems for layout recognition from IBM research team from Zurich. And we just compared what's in the tagged PDF and what DocLink comes out. And this is the data. So true positives, and count here is the number of tables, not the documents. So the number of documents is smaller, 4,400. This is the number of tables. So we have this precision and recall number. So precision is how many tables are in tagged tree, which are really tables according to DocLink. So 56% of tables. And then we have recall, this is how many tables DocLink finds and which are included into the structure tree. So you see that the numbers are not really very surprising, not high, not low. So this is about the quality of tagging. So people use table structures correctly in about 60% of cases. Sometimes they forget to put tables, sometimes they put tables where these are not really tabular structures, but just for sake of formatness, for example, for keeping the format. But again, that was used by a certain AI model. Can we trust it? So what was done? And well, it's a matter of trust. How do we do that? We do manual test. So we selected 500 tables and did a human manual check. So our QA engineers were sitting analyzing 500 cases and was checking whether docklink was correct or not. And surprisingly, AI was correct in 77% of cases. Well, according to humans. Again, humans can make mistakes, but that is what happens as well. And well, we had a few undefined cases. So actually, among the rest of 23 cases, there were 10% of cases where our key engineer was also hesitant. He wasn't sure whether these are tables or not tables, who is right, who is wrong. So that's so. According to him, AI was incorrect only in 13% of cases. So it's not a very high number. And the typical undefined cases were like almost table. Well, I'll show them. So is it a table or not? Again, according to tagged PDF, that's a table. According to docklink, that's not a table. This is. Now it's a contrary. According to docklink, so red means that's table detected by AI. And again, well, you may think that maybe it's a table, maybe it's not. Difficult to say. Well, this is a very typical situation where people put forms into tabular-like structures, and again, whether it's a list actually or a table, it looks like a table because of borders, but whether it's really a table, not clear at all. And maybe this one is nice. So somebody created a table out of this, and again, lists or tables are really sometimes very close to each other. They have very similar formatting things, especially if it's one-line table, one-line list. So again, according to me, that would be a list. But maybe it's still a table. So these are just cases, and we have like 10% of such documents. So a huge collection of documents where people have problem deciding whether it's a table or not. So don't blame AIs for mistakes. Humans have about the same number of problems. Okay, so that's the last slide. I'll finish. So half of PDFs today are tagged. We still see that there are syntax issues, and we have to understand what to do with them. Maybe we have to improve specifications. Maybe it's we have to improve best practice guides. But certainly there is some work that is on PDF Station here. Well, Tag PDF 2.0 is simply not yet here, so we still have time maybe to fine-tune some standards without the risk of breaking real-world files. And the AI is progressing and already becomes quite useful, so it has mistakes only in 10% of cases, quite difficult, and still another 10% where nobody is right or wrong. And as a future plan, we might try to repeat such thing for future calls, but this depends. Well, we invite everybody to come and maybe contribute in any possible way to this project, because I think that brings a lot of important real-world data to PDF community. And here is the QR code for the form where you can submit your own questions if you're not satisfied with the data I provided here. You have more questions, and as I said, so if this data is is collected already, we'll provide the answer.
Thank you, Boris, for the interesting presentation and, I think, interesting insights.